In this video, we're going to talk about how to destroy objects. So in this one, we're just going to do a bit of a quick sample here where we're going to make it where these boulders or rocks, when they hit the player, they're just going to destroy themselves. Now, obviously, this isn't how we want the game to proceed later. So later, we're going to come back and we'll make them actually hurt the player. But for now, you do need to know how to destroy objects in your game. So this is a good example we can do with it quick here. So let's go back into our rock script. And now we already have the check in place to see how to check if we hit the player. So instead of debugging this message out, we just want to destroy ourselves. And you know what? For right now, I'm going to actually leave this message in here. So just below it, to destroy objects, it's already built into Unity. We just want to use destroy. And then open and close parentheses and the semicolon. And then we have to tell it what we want to destroy. So in this case, we want to destroy ourselves, the rock. So what we can do is we can put in here GameObject, and it needs to be with a small g. And what this is going to do is pass in the GameObject that this rock script is on. So if we look at our game, we talked about GameObjects and components before. So in the case of rock, this entire object here, and this object right here is our GameObject. So the GameObject is the parent, the main rock. If we delete the GameObject, everything gets destroyed, all these components and the GameObject itself. So if we run this right now, if we bump into it, we output the message, we hit the player, and then the rock is gone. Now, another thing we can do when we're destroying an object like this is, say if we destroy our rock, but we wanted to do something first and maybe play an animation, or we can make the rock crumble or explode. We might not want to destroy it instantly. So we can put a comma here after the object, and we see this option here, the optional amount of time to delay before destroying the object. So if we put something in here, it's going to be in seconds. So if we put 1F, this means when this happens, that GameObject's still going to be there until 1 second, and then it'll destroy itself. So let's go run this now. Okay, so it outputted that it hit the player, but it stayed there for 1 second. So this is very handy, and you're going to use this a lot in your projects where you may want to do something like this, and then we can turn off the collider so the rock doesn't hit anything, but we still see it, and it, you know, maybe it flashes a couple of times or it breaks apart into something else. So that's all there is to destroying objects. Now it's time that we're going to start making some platforms move. So to start with, we're going to focus on just making one platform, just moving up and stopping at a certain distance. So I'm going to use this platform right here, and we're going to turn it into another prefab that's a moving platform. So let's get started here. So I want to select this moving platform here. Now I'm going to select my prefabs folder, and we're going to turn it into a new prefab. I'm going to rename it to be moving up platform. And later we'll change that because it'll do more than just move up. Okay, so now I can click and drag it into our prefabs folder. Okay, and we want to select the option that says original prefab. So this is telling us it knows it's already a prefab. Do we want to change it, or do we want to make it its own prefab? So let's do this one. Okay, so we have our moving up prefab here. So let's go select this one. And right on it, I want to add a component. We're going to make a script. So I'm just going to call this moving platform. Let's add this script. Okay, and now we're going to open this up. All right, so the first thing we're going to want to do is be able to set a speed for how fast it's going to move. So remember how I mentioned if we want to change a value in our game in the editor, we want to use serialize field. Okay, and now we're going to make a float variable, and I'm going to call it move speed. And I'm just going to set it to be equal to 1 right now. and then we can change it while the game's running to test it out. Okay, so we've seen a few different ways to move objects. I've explained that some of them, if you have physics involved, so with a rigid body, you want to use the physics system to move it. So we want to use either a force or a velocity. But if there's no physics involved, it's okay to use the player's transform. So let's go look at this again here. If we have our moving up platform selected, we're looking at the transform and the position. So I showed you previously that we could take the transform position and we could add a new vector 2 or vector 3 onto it. And it's going to either move to that position, or we could take the current position and add the new vector to it. So that does work for moving stuff around, but there's another way that we can use the transform to move our object, and it's something called translate. Now what translate means is basically moving the transform. So this makes it easier for us. We don't have to worry about where the object currently is. All we have to say is which direction to go. So to do this, let's just go into update. Let's do transform.translate. And as I mentioned, it's really good practice to look at the scripting reference. So I'm just going to show you that now. So you can either go right to the Unity documentation, or you can just use Google and just Google Unity transform.translate, and this is going to come up. So now if we look at the description, moves the transform in the direction and distance of translation. Okay, and then it gives some more advanced stuff we don't have to worry about yet. And then it gives some examples showing how to do it. Okay, so we don't need to dive too much into this. I just wanted to show you this page and make sure you get used to looking at them. But let's go in here and I'll show you as we go. So we use transform.translate. And now we need to put a direction in here. So Unity has a lot of directions built in, where normally we would have to do it like I showed you before, where we would do a vector 3 or a vector 2. We'll just use vector 3 in this case. We could say direction, and then we could do like new vector 3, and then we could say something like 1, 0, 0. And this would be moved to the right 1 unit. Now for any of these directions that are in a regular direction, either left, right, up, down, Unity has, I guess you could think of them kind of like little shortcuts built in, so we don't have to do that every time. So what we can do in here is we can use vector 3 dot up, and all this does is it's the exact same thing as putting vector 3, 0 on the x, 1 on the y, 0 on the x, or 0 on the z. So what this means is move upwards 1 unit. This is the exact same thing. So it just saves us having to type all of this. Okay, so we already have that built in. So let's use this. Now we want to also actually use our move speed. So let's multiply it by move speed. And then remember, anytime we're not using physics, we want to do time.delta time. Otherwise, it's not going to take into account the frame rate. So let's just go run this and let's see how our platform moves. Okay, so our platform's moving up. And just to show, even though it's not using physics, our player can go and jump on this platform, no problem. So we can move on the platform. It's just when we bump into it, we're not going to move it like if we hit the rocks because it doesn't use a rigid body. Okay, so we have that going, but with this code, our platform's just going to infinitely keep moving up. It's never going to stop. So we need to set something to tell it how far it's going to move, and then that it should stop. Again, let's make a serialized field. Let's do a float. And let's call this distance to stop. And I'm going to set this just as 5 right now. And I'm going to show you in a moment why I want to serialize both of these. Because we want to make our objects usable throughout our game, where we can just drag and drop them in and we don't have to worry about going back to the code all the time. Okay, so we know how far we want to go, but we don't have a way to check that yet. So the first thing we need to do is we need to know where our platform is going to start. So I'm going to make a vector3 variable, and I'm going to call this start position. Now inside of start, as soon as we start running our game, I'm going to make the start position equal to the current transform.position. So then wherever we drag that platform in our game, as soon as it starts running, it knows that's the start point. Now what we have to do is keep checking if our current point is far enough away from the start point that it's 5. Now again, Unity has lots of stuff already built in that we're going to learn about here. So they took care of almost all of this math for us. We can just use an if statement. And then if we do vector3, there's a method in here called distance. And again, I'm going to bring up the Unity scripting reference. And just in the search here, I'm going to put vector3.distance, just so we get in the habit of looking at this. Let's go take a look at it. So the description says it returns the distance between A and B. And that's exactly all it is. We have to tell it one position and then another position, and it's going to return how far they are. So this one's pretty straightforward. Okay, so let's give this a try. Vector3.distance. We want to put the start position and then our current position, which is transform.position. And now remember, this is an if statement, so we have to tell it what we want to check. So we want to say if it's less than, so we want to say if it's less than this distance to stop, do all of this code in here. So I'm just going to cut this and I'll put it right in here. Okay, so now just going through it quick here. So we check if the vector3.distance between start position and our current position is less than the distance to stop, keep moving. But then if it reaches that, there's no more code here, so it's just not going to do anything. It's not going to move anymore. And that's exactly what we want right now. So let's go test this. And if we want, we can take, here's the moving platform, so it's at -3. So if we look, this should be 5 units away, +2. So it should stop right there. So we run our game, it's moving up. And there it stops. So now it's just going to stay there and be stationary. Okay, so that looks good. And just since I realized it, I noticed every time we're jumping, our player can't reach on top of these. So I'm just going to tweak my jump a bit. Let's try 6. Oh, that's almost there. So I'll do a 7. And these kind of settings we're going to tweak as we go, but feel free to change yours however you want them. Okay, so there, we have a really big jump now. Okay, so that's working. Now what I want to do quickly before we're done this video, I just want to show why I made these two values serialized, or serialized field. So if we look at our moving up platform, we can now copy this into our game anywhere we want, and we don't have to go into the code. So if I want to set the speed of this platform different than the one next to it, I can do it right here. And if I want to tell it how far to stop, I don't have to go into the code either. I can just set it right here. And then with the way we got the start position in start, this doesn't matter where the platform is in our scene. As soon as it starts, it's going to check that. So this means if I move this platform up by 2 and I run it, now it's still going to move up by 5, but 5 to right here. So it's going to move 2 units higher than it did before. There we go. So we want to get in the habit of making everything modular, that we don't want to rely on hard numbers or anything preset. This way I can reuse this platform anywhere I want in my level and not have to worry about the actual code or things not functioning correctly. So that's the approach we're going to take throughout this whole course as we go. Okay, so that's it for this video. I will see you in the next one.